Okay, so now we're going to see timer as an interrupt source application. Earlier we have seen the application as in uh, time delay subroutine. Now let us see how do we use it as an interrupt source application. So here's a simple one. There's a PIC 18 and there are 4 pins LED connected to RD0 until RD3. So the task given is write a program to configure timer. Now they didn't mention which timer. So you are free to use any timer as low priority. So have this habit of underlining important points. Low priority interrupt and enable interrupt. The timer should overflow or roll over every 0.5 second. At every timer interrupt, the LED should on and off alternatingly given the frequency of oscillation is 40 megahertz. So tell me, what are the things that you managed to derive from this task? What are the points that you can derive from this task? Quick. Yes, we are using time delay timer. You need to configure the timer. What is the value of that timer? 0.5 second, half a second. So 500 millisecond, right? That's one. What else? Yes, low priority. You need to configure the interrupt right now. You need to configure the interrupt. So you know that at every 0.5 second, we already gone through the concept of the theory of timer, that is, each time when it rolls over, it will cause that flag to become 1. And in this case, we will have to configure the interrupt. So when interrupt happens, where will the PC go? In this case, what is the address that it will go? 08 or 18? Why 18? Because it's low priority. So at 18, then you should have your interrupt service subroutine, right? So what is the task that you're supposed to do? On and off alternatingly. So which means if one time is on, the second time will off. And then third time off, on, off. So it alternates. So in the interrupt service subroutine, what is the first thing that you should do? What do we always do? Clear the flag. Very good. And then the task and then RTFIE, right? But for timer delay, there is something additional. So we will see. So first and foremost, we need to do the calculation. We need to find out how many clock cycles do we need. So what is the prescaler bit that you want to use? Choose any value. 16. Okay, we already used to 16. Choose some other number. 32. Because the same number only. I just choose something and we already done 16. 1. 64. Okay. So calculate. We're using 64. How many clock cycles do we need? $78,100. Everyone got this? Is this a valid? No, so you can't use this. So 1 to 8. So 1 to 8, you get half of it. So how much? 39,000. 062 is it? 062. Okay, you can ignore that 0.5. It's a small point. So don't get panic. So during your example, you never have point. Now I got point already. So either you can leave it as 062 or 063. Up to you. So this many cycle is required. So you need to find out the the starting value, right? Starting value, so 65,535 minus with 39,062, you get 26,473. So what is this value in hex? $67, $69. Everyone got this? Everyone please do the calculation. If you don't do it now, then. So these are the values that you need to load into. So this one you load into. Let's say we decide to use timer 0 low. Why? Can you use timer 01? You can't, because it's 40 mega. So we have to use timer 0. So here we have timer 0 high and timer 0 low. So is that calculation done? So now we can actually start to write the program. So when you write origin, so here because it is low priority 1.8 and I do not know how much space to leave, so I'm going to use go to interrupt service routine timer 0. Is that okay? So done with this. So there's some marks for this also, so you'll get some marks. So then start. So what is the first thing that you need to do? Configure the port. So the port is going to configure add output, right? So we can just clear F3D. The initialization, it can be on or can be off. Doesn't matter. So which one you want? Off. So clear F port D. So done with the initialization. Configure initialization done. What's next? Configure interrupt. Okay, very good. So what is the first thing that we want to do in interrupt? Bit set, Archon, IPAN. Of course, if you follow the SOP, the first thing is to identify what is the interrupt source. What is the interrupt source here? Timer 0. So second thing, identify the group. Which group? Core group. What is the third step? Enable the priority scheme. So what is the fourth? Which is now we need to configure those 3 control bits, right? The flag, priority, and enable. So where is timer 0 flag? So what we want to do the flag? We want to clear, and it is in incon, right? So timer 0 flag you want to clear. What you want to do with the priority? Now where is timer 0 flag priority? Now which register? Incon, incon 2 or incon 3? The priority bit is where? Is in incon 2, right? So what you have to do with the priority? Low. So you have to clear. So it is in incon 2 timer 0 IP, and then you have the enable bit which is in incon timer 0 IE. Are we done? Global all right, because this is core and this is low priority, so we have 3 levels of enabling. You have enable local, you have to enable the global all right, which is in this case I'm just going to write GIE to indicate I'm enabling all. Then you also have to enable the global all, which is GIEL. Done with the interrupt configuration. What's next? This is the main program. But what's you missing now? What configuration you need to do? What subject are we learning now? I don't like micro PE. Stop topic. What are we learning about? Timer. What we should do with the timer? We should configure the timer, right? That's what you did the calculation what is now. So you configure the timer to generate 0.5 second, right? So you need to do that configuration here. So you have chosen 1 to 8. So what will be the value? Move LW hex 8. So 1 to 8 is what? What is the prescale bit? 4? 111. 111 is 256. This is 258 is 101, right? Sorry, 110. So 110 is what? 6. Bit number 6. And you move it to top on register. After you configure, what you have to do? You have to load the starting value, right? So what is the starting value that we have found out just now? So we found out 69, 67. So we load 69. We load it into timer 0 low. Then 67, hex 67, we move it into timer 0 high. What's next? Here we don't have to do polling because we have already enabled the interrupt. So what we do now? We wait for the interrupt to happen. So we can actually put NOP branch wait. There's no more additional task for you to do, right? So are you able to see the flow? The main program, you configure the ports, you enable the interrupt. Then you configure the timer. So here, so you configure input output. Here, you configure the interrupt. And here, configure timer. And here, wait for interrupt to happen. Right? So you have configured the timer. So it will wait. So when 0.5 millisecond is over, what will happen? Timer flag will become 1. When it becomes 1, what happens? The PC will save the next address into the return address tag, and PC will go to 18. And at 18, you have written go to interrupt service routine timer 0. So you have to write that down here. Interrupt service routine timer 0. So what is the first thing that you always do? Clear back the flag. So which is in incon. Now in a normal interrupt service subroutine, you clear the flag and do the task. But here you have to do something more. Can anyone guess what is it? One more step you need to do. It has something to do with reset. Clear after the timer flag is done. What do you have to do next? If you want it to always count the same next time. Yes, you have to reload back the starting value. We have to reload back the starting value right into the timer. You're getting the point or not? When does interrupt happen? when timer flag becomes 1, right? So it means the content of timer becomes 0, right? So when it becomes 0, you have to immediately load it back with the starting value so that it will continue to count for the next 0.5 millisecond. If you don't load the value back, only for the first interrupt it will be 0.5 second. The other interrupt will be longer than 0.5 millisecond because it is starting to count from 0. Got the point? So the only thing additional that you have to do here is you have to repeat back these lines. You have to load back that 69 to time 0 low, 67, load it back into timer 0 high. So you have to reload back. So here you clear the flag because the flag indicates that that is already the reset or the rollover. If you don't clear the flag, what will happen? When you go back to main program, it will come back to interrupt because the flag is 1. So you have to clear the flag and you have to reload back the starting value. Because timer is a separate module. Timer, once you start, it will start to count by itself. It's a separate module. It's not dependent on the main program. Once you start it on, it's a separate module. It starts to count by itself. So whatever the main program is doing is independent. It will continue to count. So the moment it reaches the maximum value and rolls over, the flag will become 1 and it will cause interrupt to happen, right? So when it causes the interrupt to happen, it will call the interrupt service subroutine. So the first thing that you should do is clear back the flag because you don't want interrupt. You don't want when it goes back to the main program, it will come back to the interrupt service subroutine. So you should clear back the flag and then you should reload back the starting value. Because when it resets, when the F flag becomes 1, the content of timer becomes 0. So you don't want it to count from 0 until 65,000. You want it to count from hex 6769. That's the starting value. So that's why you have to load it back. Then you can do your task. So the task is to complement. Sorry, I gave out the answer. The alternate. So you can use comp F port. Thank you. Complement F means it toggles the entire port. Stop back the answer here. So this is the only task that you have, right? And after this, return from interrupt. Now take note that I've always given a very simple task. However, depending on the task that you have, they have to write. But what I'm trying to show you here is the format for timer interrupt. For timer interrupt, the format is clear flag, reload back, and then only comes your task. Then RETFIE. So this is your task. So let's see the entire flow. Let's see the entire flow. So you configure the ports, then you configure the timer, and then you configure the interrupt for the timer, and then you configure the timer, and then you wait for the interrupt to happen. Because for this particular example is the easy one. Maybe later on I can give you a more difficult task for you to think and do. But because the main program has nothing to do, and no other task, so you just wait for the interrupt to happen. So when the timer finishes off and the flag becomes 1 and resets, that will cause the PC to go to 1.8. And here you have written go to interrupt service subroutine. So once you go to the interrupt service subroutine, you'll clear the flag, it'll load back the value, and it'll complement. So earlier it was off, right? Now it will be on. And then return back. So return back, you'll come back here, wait NOP branch. While you have already loaded the value, it is actually continuing count. It is already continuing counting for the next 0.5 second. So while you're waiting, again 0.5 second finishes, the flag will becomes 1. Again, it'll go to the interrupt service routine, we'll come back here, clear the flag, reload back the value, and now complement. So now it becomes off again. So every 0.5 second, it will go to the interrupt service subroutine periodically. And because the complement, it will be on, off, on, off, on, off. So this is how you apply timer as an interrupt application.